This is power series. And what are power series? Power series are in the general form of this, and from 0 to infinity an x minus c to the power of n. But we usually consider the power series in which c equals to 0, like the one we use for solving the differential equation. Okay, now, but it's not like that all the power series are convergent. And let me see. We should find that for which x's or which situation these power series are convergent, or a given power series is convergent. Okay, I find the values of x in which this convergent in the video for the nth root test. Remember? Let me do it again fast. If the limit of this as n goes to infinity be smaller than 1, it is convergent. If the limit be greater than 1, it is divergent. Okay? And what then? Suppose this equals to the limit of absolute value of an times the limit of absolute value of x. Okay, and let's call this L, the limit of this L. So that would be equal to L times, and this doesn't depend on n, so that would be this. Now this should be smaller than 1, so the absolute value of x should be smaller than 1 over L. And for this value, which which x is between 1 over L and minus 1 over L. Again, out of screen. Be 1 over L minus. Okay, for these x's, the series is convergent because it is absolutely convergent for these values of x, and so it is also convergent. But for when the absolute value of x be greater than 1 over L, greater than 1 over L, you know, this series diverges, okay? But what about the original series? This, you know, without the absolute values, you know, it turns out that this is also divergent for this value, for the x's in this, you know, x here, from here, x is greater than 1 over L or smaller than minus 1 over L. Okay? So, you know, and I may give you a proof in some later videos, but you know, for now, please accept it from me. And we call this 1 over L to be the radius of convergence for this series. Okay? Okay? You know, here L times the absolute value of x is smaller than 1. You know, from here, if the L, which is the limit of the nth root of an, if this be 0, then whatever x would be, this would be 0 and it is smaller than 1. So in that case, our power series is convergent everywhere for every values of x. Okay, let's have some example of this. What about this power series? Infinite. You know, this is 2x to the power of n. Okay, this is the geometric series also. You know, the geometric series is a special case of power series. Okay, so you know, but let's do it by the method I talked about in the previous video. Okay, what is the limit of this to it? Sorry, we should do that for the absolute value of that. Sorry. Okay, this is 2 absolute value of x, and this should be smaller than 1. So this series is convergent for these values of x, or x between this and that. Okay, you know, but the calculation of limits here was easy. But what about we got something like that, for instance, the limit of n approaches to infinity of, something like over n factorial. It happens. It's not strange. I talk about how to calculate this kind of limits in some videos later,